All right then. For our next and last talk is about LLM ops. It's relatively more a recent topic, so thank you so much, Lydia, for accepting to share your experience with us. And yeah, with no further ado, uh, over to you, Lydia.
Okay, perfect. Then, good. Then I get started. So exactly. My name is Lydia, and yeah, I'm currently working as an AI engineer and consultant as a freelancer. It's been just 1 year actually, and I also started a startup in the HR tech field with one of my first clients actually as a freelancer, Blackstar AI. And yes, we're aiming to revolutionize the way recruiting is done with like ethics and unbiased um, approach as much as possible. And yes, as a freelancer, I also work on lots of different projects around mostly generative AI in many different fields. It's just been 1 year, and I've helped projects with from finance to veterinaries, fashion industry, teachers, etc. So really interesting and diverse. And prior to that, I was working at Amazon as a language engineer on Alexa, and before at Apple, also as a language engineer on Siri. So in the natural language understanding teams. Yeah, so this is for my background. And um, today I am talking about LLMOps, so large language model operations. And yeah, of I guess everyone knows what large language models are and how they relate to generative AI. But just to go again, right. So AI, when people talk about AI nowadays, and in particular, not technical people, we usually talk about generative AI, and we imagine ChatGPT and the technology behind ChatGPT and all the generative AIs. At least the models behind them are large language models, and they are built um, on the architecture that is not that new, like the Transformers architecture at like 2015, I think. But it's just in the recent years that they have been able to train model at such a large scale with so much data and a huge number of model parameters that we got these really advanced language generation models, and that are now revolutionizing pretty much every single industry. So yes, the very first item in the LLMOps landscape, it's obviously those large language models. And and the second thing that is pretty important in this landscape is the fact that these models are now so large. We're talking billions of parameters that companies are offering access to those models via API as a service, and with offerings like OpenAI API, where you pay per usage, pay per token, actually. So this is really a major component of the LLMOps today, I would say. So it's not only the model itself, but also how is it provided, how do you access it. Next, prompt engineering. This, I guess everyone heard of prompt engineering. Everyone is a prompt engineer, at least up up to a certain point when you chat with ChatGPT and you try to get it to get the right answers, or yeah, to guide the answers. So it is quite unique not unique, but to large language models, where we really try to guide the output of the models by refining the inputs, the prompts. We can see like a comparison maybe with the search engines, for example, that would try to optimize the query that would retrieve the most relevant results in their search engine like recommendation system. So there are parallels to prompt engineering, but it's really it takes such a big place in the LLM environment. And finally, well, yes, a lot of tools that are around those language models, orchestration frameworks that are very popular, like LangChain and Llama Index, so that have been created specifically for LLMs, but also vector databases that are not specifically for LLMs, that existed before that, but are now very popular. A tool to use together with an LLM in the context of retrieval augmented generation. So now, to follow on Christian's talk, there are a lot of things in common between LLMOps and MLOps. I'm going to try to highlight some of the differences, maybe, or not differences, but things that really stand out in LLMOps as opposed to just general MLOps. And the first thing, as mentioned earlier, and that everyone knows, and it's even in the name, it's the size of the models we're talking about, the computational resources and the costs. Yes, like billions of parameters, $100 million to train a model like GPT 3.5, I think. So this is just, talking about the scale of the models we're talking about. And kind of direct consequence of the scale is the second point. It's the transfer learning, the fact that in generative AI, when working with LLMs, we basically rarely, or I would say never, train a model from scratch, but instead start from a foundation model and fine-tune it to adapt it to our needs. Yes. Then again, third point, prompt engineering. That it's maybe not so prominent in the traditional machine learning, but it is a major aspect of working with LLMs. And I have another slide. The human feedback. Because with large language models that generate text, as so their output is open-ended. It has been very difficult to train those models with just the standard training techniques that have inputs and outputs and that are fed into the model that's training. And then the model parameters are adapted based on those inputs and outputs. So for LLMs, all of the popular LLMs and the models behind ChatGPT, for example, have this additional process that is integrating human feedback in terms of human preference. So where humans are asked which of two outputs they prefer, and this is used as reinforcement learning to update the model parameters. And it is a necessary step on top of the standard model training. And again, last point, because of the open-ended outputs of the LLMs, we do not have access to, most of the time, to standard performance metrics, such as accuracy, like a F1 score, precision retrieval, yeah, it would be amazing to have this when working with LLMs. Unfortunately, most of the time that is not the case. There are other ways to evaluate LLMs other than with traditional metrics. Popular approaches are using other LLMs as judges. It does sound a bit like the egg and the chicken, I know, but well, this is this is where we are though nowadays, mostly because of the challenge of the open-ended outputs. Okay, so how do we start LLMOps project? As I said, you will probably not start by training a model, but rather start with a foundation model. The first thing that comes to mind is the proprietary models, like again OpenAI or Claude, and from via the Anthropic API. And kind of as opposed to those proprietary models, we have the open source LLMs. Popular ones are Llama 3 from Meta, or Mistral AI from France, where I'm from, so proud of it. No. And a ton of other open source models, all available on the Hugging Face hub. So how to choose, that's the first step, and there's a million possible reasons to make this decision. You can look at the performance, and proprietary LLMs tend to have best overall performance. I think my next slide quickly. So the Chatbot Arena LLM leaderboard is a very popular project to compare different LLMs. Basically what they do is that they use like community or crowdsourcing. So anyone can, it's just displayed, you can ask get a prompt, and you get two outputs. You do not know which models produce which outputs, and then you vote for your favorite one. And then the models are ranked with the ELO rating system. And it's one of the most popular way to compare LLMs at this day. And as you can see, the top, actually I don't know, the top 9, more than 9 models at the moment, that screenshot is from a few days ago, are all proprietary models. So yeah, this is probably one thing to consider when choosing a foundation model, the performance versus open source models that have the advantage of being customizable, because yes, you can fine tune them. Also the privacy aspect, because open source model can be self-hosted, versus of course proprietary models, you are sending your data to these other companies, other servers. They usually say they won't use your data to train their own models, but you know, privacy. And yeah, and always with working with open source models, there are also open source models that are very performant, but then you have to look at the size of the model. Here again, hundreds of billions of parameters, and it is going to be very expensive to host this and serve this kind of huge open source models. So when working with open source models, you will always have to face the cost quality trade-off. It's very unlikely that you will, if working with open source models, that you will be working with those biggest, like Grok kind of open source LLMs that would cost thousands of dollars per month to just serve. And yeah, and the cost is actually, there's not, it really depends on this usage, on if you or your company already has like GPU compute instances or not available, or if those needs to be like taken into consideration when comparing the costs. So there's no, it could be cheaper in some use cases to use proprietary APIs with a paper token usage, and in some other cases, not. Yes, so we saw that already. So how do we access these models? The proprietary models via API, that's the easiest way, of course. The open source models can also be accessed just as simply via APIs with companies that provide inference as a service. In particular, I've been working with Together AI, but I know there's many other, it really abstracts almost everything, so you don't have to worry about infrastructure or setting up or managing the infrastructure. And similarly to the proprietary APIs, like OpenAI, Anthropic, etc., then you can just pay per token for open source models. But if not using these inference as a service platforms, then you will probably require GPU compute to serve LLMs. And in this case, there are obviously the traditional cloud providers like AWS, GCP, etc. And maybe easier to use are some like GPU specialized cloud providers like RunPod that I have been using, and really very easily allows you to set up and spin a like GPU compute instance, and they have like really easy to use templates. So yeah, and then of course you will need the library to serve and like run inference on these models. The last one here, Ollama, is a very popular one when running models locally. So there's like some quantization. Sorry. So LLMs can be quantized run in actually locally on CPU or computer grade consumer grade machines, and Ollama is probably the most popular framework to run and serve models locally. And here all this was only to talk about the foundation model. Now usually with LLMs, it's not just about using a foundational model as is, but you will want to adapt it to a specific task, use case. Yes. And the three main approaches are prompt engineering. So in this case, we only work on the input, craft the inputs in order to guide the model generation, but the model parameters themselves are not modified. Retrieval augmented generation is again not modifying the model parameters, but is basically augmenting the knowledge by adding context into the prompt, and this context is retrieved dynamically, so in this RAG pipeline based on the initial request. And then the third aspect is fine-tuning, so really from the foundational model modify the parameters, or like Kristen presented earlier, there's a lot of fine-tuning techniques like adapter-based, but in any ways the idea is that the model itself is modified to adapt to our needs, our requirements. And of course, these three techniques are not at all exclusive. Actually, most of the time, it's a combination of two or three of them that you will have. So let's start with prompt engineering. And as I said, everyone can be a prompt engineer, is a prompt engineer when talking to ChatGPT. However, with LLMOps, I think a very important aspect of LLMOps is the way we manage those prompts. How do we iterate on them, and so I'm not going to go to talk about the different prompting techniques. There's lots of techniques. Just named a few here, but I really don't think that the techniques is the right way to start or to look at prompt engineering. But it's really about having the right approach. So how to not do prompt engineering. And here I'm talking about examples that I have seen in businesses, like real case companies. For example, having a 3 pages long prompt in a Google Doc without testing it before on real data. Yes, so that's not how to do it. Also having like hard-coded prompt in the code and just testing it end to end in the app. Also not a good way to iterate or work on a prompt, do prompt engineering. So here I listed a few tools that are basically doing this prompt management tool, and I think hopefully have a bit of time to demo one of them, Prompt Layer. I should have it here. So here is what I think is the right way to do prompt engineering. It's to first start with a data set. In my case, this use case is we're using LLMs to grade student essays. So here I'm using Prompt Layer, and I have a data set, very simple, with the student submission, a column with the student submission, and a column with the expected grades. And then in Prompt Layer, I have my prompt that you can create. Here is the system prompt, and it takes us, and you can add to the prompt like variables. So in my case, I have a single variable here, submission. And basically this prompt is very long, but it just asks the LLM to grade the student essay. As you can see, there is versioning. So every time I make a modification to the prompt, all of the versions of the prompt are tracked, and there's a comment most of the time on what was the change, and there's all sorts of like logs accessible if the prompt has been used here. And what is really good with Prompt Layer is that you can create an evaluation pipeline. So here, for example, I have created this pipeline. Let me go through the columns like quickly. So the first 3 columns here that are grayed out, this is because it loads my data set that I showed before. So it inputs the student submission, the expected grades, well, the ID. And then I run the input through my prompt that I showed earlier, actually 3 times, because for this project we're doing majority voting. So in order to increase consistency in the grading system, we score it 3 times and then we take an average. Basically this is the evaluation pipeline. Inputs, then the submission are passed 3 times to the prompt, so we get 3 outputs, 3 grades, and then we get the average of those 3 grades. In the next column, we check the variance. So in this is something, for example, we want to see if the 3 times we graded were actually aligned with each other or not. So when the variance is 0, it means that we graded 3 times with the same scores, but when it's not 0, it means that we assigned at some different scores sometimes. So that's going to be interesting to look at. And then the MA8 to the mean average error, and this is as compared to the expected grades that I had in my first column. And then a simple like pass Boolean or not if the MA is 0 or below a certain threshold. Basically, so of course it takes a bit of time to set this up, but once it is done, it means that you can work on your prompt, and then every time a prompt is edited, it triggers automatically the evaluation pipeline I showed before. So for this, am I not looking at the right? Yeah, so for example, here okay. So here I can click here. So for when the prompt was at version 16, and this is the evaluation that was run, and I can see an average MAO score of 0.03, and so on. So I can keep iterating on the prompt until my average error score goes down or below a certain threshold, and so on. Yeah, so I hope this demo was clear. We can get back to it later when we do the questions, if you have any. Okay, back to the slideshow. Right, so yeah, so that was prompt layer. The other tools basically offer similar functionalities. LangSmith, I guess it's the most obvious tool to use if you are already in the LangChain ecosystem. LangChain is the orchestration framework for LLMs. Yes. Then next, I'm going to talk about retrieval augmented generation. And well, here again, only from an LLMOps point of view, because honestly, I mean, I think RAG itself would deserves a whole talk, like probably a 1 hour talk, just to talk about RAG. And here again, lots of different techniques, lots of like approaches, how to augment the knowledge of the LLMs. Usually, so we have an external data source, and we use a semantic similarity approach via vector search. So yeah, the external data source is vectorized, and yeah, the vector search similarity retrieves the most relevant context to a user query, and this context is injected in the prompt and then sent to the LLM. This is how the knowledge is augmented. So of course, that's why we need vector databases, because the external knowledge is when it's ingested and chunked, and every chunk is embedded into a vector representation stored in a vector store or vector database. But again, trying to keep the LLMOps point of view, what is important here, because we're talking about data, is also the data versioning and the continuous data integration. So in RAG, creating this knowledge base or this vector base, it should not be seen as a one-off task. So yes, like I said before, how to not do prompt engineering, how to not do RAG is dumping a lot of data in a vector database and connecting it to an LLM, and yeah, considering that this is a RAG pipeline. If the data is not versioned, if you cannot reproduce setting up this database or the ingestion pipeline, how was the data chunked, cleaned, maybe process embedded with switch model, embedding model, and all of the ingestion parameters like the chunk size, the chunk overlap, the chunking technique, using a ranker or not. No, sorry, this is not related to the ingestion, but and also and the second thing is it's not a one-off task. In general, it's really important to, from the start, think about how can we have this data integrated, so continuously refreshed, updated. We need to create pipeline, could require API integration to live sources, or really any other traditional ML ops approach to connecting data sources. So like Kristen mentioned earlier, like Kafka for streaming data, for example. So all these is essential in RAG, as opposed to just having this static dump of data in a vector database. And then the second aspect of RAG I want to mention, again, from an LLM ops point of view, it's the evaluation. So as I said before, evaluating LLMs can be difficult. And yes, in my demo before with the prompts, I did pick an example that was quite easy because, of course, it was about grading students. So my output was grades, scores that are easy to manipulate, calculate averages or errors, etc. This is actually not most of the time the case, most of the time, but for RAG, it is there's still approaches to try to evaluate the quality, the performance of a RAG pipeline, and the most common framework probably is RAGAS, but it's usually when we evaluate RAG, it's usually kind of a variant of this idea, this approach, where first we want to decouple the evaluation of the retrieval step from the generation step. And retrieval step, I mean retrieving the chunks of data that will then be injected in the prompt and sent to the LLM. So which chunks are retrieved from the vector database, this is the retrieval step. And then once those chunks are in the prompt and sent to the LLM, that's the generation step. So the concept is to decouple the evaluation of the retrieval from the evaluation of the generation, and then looking at the retrieval step, for example, you can look at the context precision and context recall. So, of course, this requires to have evaluation data sets where for a certain query you have the expected chunks to be retrieved, and then you can check is the chunk I was expecting to retrieve present in the context? Yes, then this increases the precision, and similarly for the recall. And right, again, for a RAG, like I said before, there are so many parameters that can be tuned, like the chunk size, the chunk technique, the overlap, the embedding model, query transformations, and or iterative retrieval. There's a lot of things. So even though we are actually not modifying any machine learning model, because we're not fine-tuning a model here, I still think that a lot of the LLMOps concept apply. So first, of course, the data versioning, data management mentioned earlier, and then also experiment tracking. So I have been using weight and biases, but I think MLflow would also, the experiment tracking, like functionalities of MLflow would also be helpful here. And where the idea would be to create an evaluation data set, actually one for the retrieval, one for the generation, and to run different experiments with different RAG parameters, configurations, and track these results and version the data, etc. Checking the time. Okay. Next, custom models. So this is about actually fine-tuning those foundation models, and here is probably where we have the most overlap with LLMOps. So the first thing to create a custom model is to have some data to fine-tune. The data, I mean, in the best cases, it's proprietary data that you already have, but often, at least with startups, it's often the case where there's actually no data. So how to get the data? There's this tool, Orgilla, that I like to create training data with human input, like human labeling, and Distilabel that creates synthetic data. It's really popular with technologies like LLMs that generate text to actually use those to create synthetic data. But in any case, with again, I'm just repeating myself a bit, but anytime there's data involved, and in this case, this data is like training data for custom LLM, but it really it's really the same thing as in our previous use case with retrieval augmented generation. We want to version the data, to validate the data, monitor the quality. The standard garbage in, garbage out applies, of course. Data privacy considerations and the continuous data integration. Again, it's not a one-off process. Yes, here is the same. You don't want to just fine-tune a custom model and not keep track of the data and just have that model and use it and hope everything is going to be fine, because it's really important to keep reproducibility and evaluating that model and evaluating it once in production as well, like for data drift, etc. So how do we actually fine-tune the custom models once we have selected the foundation model and gathered the training data? Sometimes it can be very easy. Like OpenAI API, the platform allows you to fine-tune a model from the UI. It's really, really easy with just a few clicks, no code, just upload a data set, and actually prompt layer as kind of a wrapper around the OpenAI fine-tuning API. So like the tool I was showing before for the prompts, you can also directly fine-tune from prompt layer. This is very user-friendly, but of course, you don't have control, and it forces you to use the OpenAI models, and at least very little control into how the fine-tuning happens. So there are alternatively the other options then is to fine-tune open source models, and for this, there are a few tools like Together AI, again, that I mentioned earlier, that provides inference as a service. Also offer functionalities to fine-tune those models, and that are then hosted and served by Together AI. That can be accessed via their API. So again, serverless, like you don't have to worry about the infrastructure. And similarly, Ludwig AI, and they provide really easy templates to fine-tune open source models, YAML templates for Ludwig AI, for example, which makes it really pretty easy. So here again, you have to have your data set formatted in the right way, with the data versioned, and then using these tools, it is quite straightforward to fine-tune a model. But then, of course, you can go full on with Amazon SageMaker, and directly using the Transformers library from Hugging Face, and go even more advanced at this, of course. Because we're training custom models, this is the class standard MLOps principles that apply. Model versioning, registry, experiment tracking. Yes, I'm just repeating a lot of what Christian said. Yeah, I think this is it for this section, because a lot of overlaps with just MLOps. Next, in general, observability. Like tools like Prompt Layer or Langfuse, that are prompt management tools already, they all offer also observability features. So they will log the LLM traces and actually display a trace timeline. So here it's a screenshot for another project I'm working on, and where you see that the main the main process was called document eval, and then as part of document eval, I had a first main process called evaluate content, and then actually later on I had another one that was evaluate style, and then for the content I had like an evaluation of the brand, the team, the traction, product text, etc. And with Langfuse you can see every step of the of the process and how long it took, and the overall trace timeline. So these functionalities are included by default with the prompt management tools I showed before. And they also work pretty well with RAG. So in this example, there's no RAG, but actually you could also have some of those funds to be the retrieval steps of the RAG pipeline. And yeah, so have like really an overview like of what happens in your system. And yeah, there's plenty of other observability tools for LLMs. Some of them are, and yeah, those three tools are more comprehensive than just the prompt management tools that with the LLM traces before. They are, they also offer like really monitoring features as well. So with alerts in case, yeah, so you can set alerts based on certain parameters. Yeah. So I think, yeah, almost at time. I will quickly go through the last slides. I just had just to summarize again everything I said. The easiest LLMOps setup for me is just using the OpenAI API or Anthropic API, not worrying about the infrastructure, but the prompt management tool, for example, prompt layer. This is almost mandatory, I would say. And then of course the basic DevOps, so code versioning and CI/CD integration and continuous development pipelines. Then for example, a level 2 would be pretty similar, but adding RAG, retrieval augmented generation. And here we want the data management best practices, evaluating the RAG pipeline, tracking the experiment, and again, the DevOps obvious aspects. I did a level 3 where we this time train a custom model, but with a tool like Ancelos AI that abstracts a lot of the a lot of the steps, makes it like easier to get this custom model. Also using like runpod to spin up like GPU instances, and yeah, and again data versioning, experiment tracking, and all the good things from DevOps and MLOps. And I think we did a level 4. Here we go a bit further. This time using Amazon SageMaker and yeah, AWS like instances. This makes more sense, of course, if it's a larger company that is already using a cloud provider like AWS or Google or GCP or Azure. And in this case, you would also want a much more comprehensive like observability and monitoring setup. Yes, I think yeah, I think this is it. Yeah, there's many many more aspects to LLMOps. I think that haven't touched here, like, and really. I don't know, like the orchestration frameworks, like LangChain, Llama Index, or the agentic frameworks, or just using guardrails, or structured inputs and outputs. But I hope this was still an overview of LLMOps and how it overlaps with MLOps and the specificities of unique aspects of LLMOps, like the prompt engineering. Okay. Are there any questions? Oops.
Yeah, Christian
Yes.
is raising hand. Go ahead.
Thank you for this insightful and comprehensive talk. You mentioned at various points working with startups or companies on different solutions. What are some of the biggest challenges you notice with respect to making solutions involving LLMs and or LLMOps?
From my experience, the biggest challenges are not technical challenges, but is like working I think my biggest challenge is with generative AI. It's so easy to have like a demo or something that looks really cool and so powerful in a couple of hours. But actually, when you try to operationalize this, it gets really complex. And I found it very difficult with like customers, companies, clients to justify the fact that even though the prototype was ready in a couple of hours, the actual product will take months. Because yes, I may probably the challenge of evaluating the outputs of the LLMs. For my demo, I picked the easiest use case where the output is numerical scores, so those are easy to evaluate. But most of the time, it's not like chatbots. How to evaluate chatbots, and because it is so difficult to evaluate, I find that the iterations on the product are pretty slow, and it's even just difficult to make sure are we even going in the right direction or not.
If you
And
can't measure it in a good way, like how can you
yes,
optimize?
yes, but again, per se, I would say that this is the challenge is not really in this, but it's more in explaining the clients that it is taking a long time, and as opposed to the
Okay.
first whoa, expect like the first demo, because sometimes I wish generative AI didn't make things so easy to start with, because then people have expectations. Oh, well, if you did this in a week, and then in 2 weeks we're like a unicorn startup. Yeah.
Yeah, that's a very interesting point you raised. Thank you for that answer. I obviously don't have as much experience as you, but this is also a little bit my impression. Like the prototype phase gets easier, but the operationalization phase can have
I mean, it's also
unforeseen
because
challenges.
it's pretty new
Yeah, the solutions
field,
aren't
right?
at
So,
hand, right?
and I feel like best practices are slowly coming into place, but for prompt management, for example, that maybe I mean, even tools like the ones I showed are pretty young. So I think it will take time. I see. I will definitely. Yes, so I can share my slides.
Thank you for your response.
Welcome. There is another question. Oksana?
Hi, Lydia. Thank you so much for the presentation. Super interesting.
You're welcome.
You mentioned the evaluation challenges. I was wondering if you can share some secrets approaches to creating the evaluation data sets. Is it only manually annotated data sets mostly, or?
Well, it depends on the use case. I always say that any evaluation data set is already good. So even if it's created manually and it takes time, and then there's only 10 data samples, it's already better than nothing, because it's a good way to get started. Then ideally, for example, you can get more data if your product is already being used from real users, like like gathering real inputs and the outputs of your model, and then having like humans, domain experts reviewing the outputs, correcting it, and then that increases your you can put this into your evaluation data set and increase this the size and the coverage of it. But I think that in some cases, I would do the effort to create a manual data set, even with just 10 entries. And then also, as I mentioned, definitely look into the possibility of synthetic data, at least as a first step. And then, so yeah, using like LLMs basically to create the data set. Probably you want to review it manually, but really, or yeah, like I mean, always try as much as possible or as soon as possible to have like real users data into the evaluation data set and not just synthetic data, because of course the data created synthetically is likely to be pretty different from the data that your users will give you. Recently I was working with someone developing a to-do list app, and yeah, they wanted to use LLMs just for a few things, but all of their to-do list items in their test set were so like, remind me to make an appointment at the dentist or things like this. And then I actually checked my phone and I looked at my to-do list, and it didn't look like this at all. Like, one of them said mom, and of course I know that it says mom because it means that I need to call my mom. Or so that developer was developing his product with this super clean data set that was generated by ChatGPT with a list of very well written reminders to the list items. But once the product goes into production and users like me have this kind of to-do list items, then things go wrong. So yeah, as much as possible, as early as possible, integrate real user data in your evaluations.
Thank you.
Welcome. Yeah,
Any
I
further questions?
think.
Yeah, maybe can I? Yeah, sorry to ask so many questions. Just one quick one here. For my company, we are located in Germany, and it's important if we use an LLM service that processing is done inside of the EU. Do you know off the top of your head any great LLM as a service providers that can guarantee EU data residency? Just if you know off the top of your head, professional
I don't,
tip.
no, I sorry, no, I don't, not out of my head.
Okay, I'm pretty sure Mistral
Sorry.
AI is doing it in the EU, but other than this, not sure.
Right, because then you could also just like use a cloud provider, like
Yeah,
AWS, no?
yeah, spin it up and ensure that it's in an EU region. Yeah, you're right. Yeah, thank you.
Welcome.